Now that we've taken a look at how to do a hypothesis test for one mean, we're going to look at doing a hypothesis test on what is called matched pairs, or data that comes in pairs. In order to do this hypothesis test, the first thing we need to be able to do is to identify when we're in a matched pairs situation. To be a matched pairs situation, we're going to have two data sets, and the two data sets are connected. Well, what do I mean by connected? Well, a couple examples of what that could be. The most common is we've got before and after data. A common example of this is a whole bunch of students take a test, then they go through a study program, then the students take a test afterwards. And we want to know before and after, did the test get better? Or maybe a company has a lot of customer complaints, so they do a training. And we want to know, did the number of customer complaints reduce after the training? We have before and after data that is matched per person in a set of data, before and after, so we can see the change happening. The other place that matched pairs comes up at times is when we're looking for relationships between related individuals. Like we want to know if there's a difference between twins, and so we match twins together. Or maybe we want to know if there's a difference between couples, and so we match the couples together. Those type of situations where the data is matched together, we can use a matched pairs test. But the most common time we're using it is this before and after situation. Because when we have the before and after situation, we can run a hypothesis test on the differences, not the actual values. In other words, we're going to calculate what is the after score minus the before score. We want to know how much has the score improved after minus before. So in this way, we are really interested in a null hypothesis that says the average difference, we'll do a subscript of d so we know we're talking about difference. The null hypothesis is that the average difference equals 0. There is no change before and after. Nothing happened. Then for the alternative hypothesis, we've got three options. One option for the alternative hypothesis is say that the average difference is not equal to 0. When we do that, we're interested in just whether there was any change at all in the after minus before. We don't care if it got bigger or smaller. We just want to know, was there any change? Another option is we could ask if the average difference was greater than 0. In other words, the question we're asking is, did it go up? Did the scores go up after the treatment or after the change happened? And then the other alternative hypothesis we could consider is if we want to know if the average difference is less than 0. We want to know, did the scores go down after the treatment? So those are kind of the three situations where we would run a matched pairs test. We want to know, is there any change before and after? Do we want to know if the change went up, or if we want to know if the change went down? Once we identify the null hypothesis, we will run the same t-test we used for one mean in the prior video. We'll still have our test statistic t, which is equal to the average difference minus the hypothesized difference over the standard error. But what's really nice about that is because we are assuming that mu is equal to 0 in the null hypothesis, we really just have x bar's difference, the average difference of the sample, divided by the standard error, where again that standard error is equal to the standard error of the differences divided by the square root of the sample size. So it's really just another type of t-test, another type of hypothesis test for a single mean. We've just got this extra step that we are looking at the differences, not the values, doing the after minus before. In our next video, we'll take a look at an example of running one of these matched pairs t-tests.